Having been done with elastomers, we come to the second category under classification of polymers based on intermolecular forces of attraction between the polymeric chain. And now we come to fibers. So fibers are actually polymeric chain which are cross-linked, and that too by strong intermolecular forces of attraction. So here we have nylon 6,6 before us. So straight chains of nylon 6,6. What happens is that when these two chains come in contact with each other, we have oxygen and hydrogen in both of them, and these get interlinked, and we know a force develops between them known as hydrogen bonds. So we are aware of hydrogen bonds being developed between H of NH, and then we have oxygen from CO. So H bonds over here in these polyamide will act as a strong intermolecular force of attraction between these two chains. And these are the five. So, because of these strong molecular forces, what happens is that when force is applied on these fibers, they will not extend, unlike the elastomers, in which extension was happening up to 2 to 20 times of their original size. So, here they will remain so when strong forces are applied. So, we can, saying a few words about fibers, we can say that fibers are those type of polymers in which the polymeric chains, so we are writing about the polymeric chains. So here the polymeric chains are associated, so they get associated with strong intermolecular forces of attraction. As we have previously seen in the example, that strong intermolecular forces of attraction were being developed, and these forces of attraction are mainly, those are strong forces of molecular forces of attraction are mainly the hydrogen bonds. So hydrogen bonding can be an example of these forces, as well as we have another example that can be dipole-dipole interaction. So these two forces are the ones which are responsible for holding the polymeric chains together, and this is dipole-dipole interaction. Now what happens is that because of these strong forces, we have some properties that are developing between the fiber chains. Now what happens is some properties that develop are they become compact as these intermolecular forces bring them together. So they start getting close together and they are compact. Then they have very high density, again because of them, because of this contactness, they have very high density. Next, they have high melting point. A closed structure leads to a high melting point, and these are actually crystalline. Okay, so that also differs them from the elastomers. So high melting point. Also, if we see, they have low solubility in water because the chains low solubility in water because the chains will not break as they are held by strong intermolecular forces. So low solubility in water. Next, they have no elasticity. They cannot be stretched. No elasticity. So they have no elasticity and thus they cannot be stretched. Next, and the last one is they have very high tensile strength. That is, a lot of force is required to break them. So they have high tensile strength. So these are a few properties which develop all because of the strong intermolecular forces of attraction that are between the fibers.